1, which is called Systems of Linear Equations. And by systems, that's probably too complicated a word in this case. For most of what we're going to look at, what we mean is two equations. We're going to look at two equations and two unknowns. Maybe I don't know if we actually go so far as three equations and three unknowns, but that's what we mean by a system of equations. So we're going to go at this first a little from the application point of view. I'm going to talk a little bit about some microeconomics. If you are either an economics major or business major, find this useful. If you're not, well, it's useful anyway. It's useful stuff. So, thinking about going to buy something, if you're going to go buy a TV and you saw it on sale for $20, run, not walk, right? Give it to me, $20. But if it was, say, $20,000, say forget it. Which is to say, people will be more interested in a lower priced product and less interested in a higher priced product. And there's a way to describe this with a function. So if you're the manufacturer, you can think of this as the number of sales you're going to make graphed against the price. And the graph, would kind of look like this. It's more, could be a line. We're going to assume it's a line. But the idea is, up at this high price, not that many people are going to be willing to buy it. And at some point, nobody will buy it. And at some low price, everybody's going to want to get one. So this is called the demand curve. Although, in economics, we often will try and draw an approximate line through it and make it into a linear equation or a linear function. Okay? On the other side, if you're the manufacturer and the higher the price you can get for this item, I'm going to use a different color. The more you can charge for your, whatever it is, TV or widget, the more of them you're going to be willing to make. But the lower the price, the less you're going to be willing to make. So again, there's another curve here which describes your willingness to make products. And that's called a supply curve. And again, there's some approximately straight line, linear function that approximates this. At least towards the center. On the edges, funny things happen. And you can see that there's a point where they cross. Now let's think about what that point means. That's the point where the number of units you're willing to make, is equal to the number of units that people are willing to buy at that particular price. So that's kind of useful information, right? If you make more, well, you're not going to sell some of them. If you make less, there are people who aren't going to be able to get them. you're going to lose profit. So that point of intersection is kind of of value to you as a business. And in particular, in math, what we want to know is, well, how do we find that point? That is, how do we find the intersection of two lines? Okay, I think a lot of what I'm going to show you may be review. I think you've all seen this at some time in the past. I don't know how well you remember it, but what we're looking at is two linear equations, which I'm going to write in the abstract. So this is a linear equation in x and y. Those are the variables. And a, b, and c are just constants. Some numbers I'm not specifying, but they're fixed numbers. When we do a real problem, we'll give it a number. And since we need two of them, we'll use dx plus ey equals f. Now this is this ax plus by equals, see that's, we call that standard form. It's just a form of the equation. We've seen other forms. There's the slope-intercept form, which, well, there's different letters here. I guess I'll use capitals. Y equals ax plus b, and y equals cx plus d. This is the slope-intercept form. And again, we could have two of these and we might want to solve them. And there are other forms. We saw the point-intercept flow, point-slope form, which we're probably not going to use much today. Okay, so if you want to solve one of these systems, what does that mean? That means you want to find the point here, the x and y point, that is on both of these lines. And you may recall that we have a few different ways to do this. The first way we can use is not a particularly accurate way, but can sometimes work, is this. We can graph it. We can just graph it, on a scale. We graph the two lines, we look at where they meet, and we just read off on our scale what the value of x and y is. It's often a good way if you just need an approximate number, and maybe if you have a graphing calculator that could do it for you. Excuse me. The other ways we have, well, I'm just going to list them here for the moment. So we have graphing. I hope you're familiar with some of these. There's substitution. There's elimination. I'm going to list it here, but we're not going to look at it. You can use matrices and something called Gaussian elimination. I'm not really that interested in this. And there's also something called Cramer's rule, which if you get into 3 equations and 3 unknowns, 4 or 5 or 6 or something, if you want to do this on a computer, Cramer's rule is really good to know. But we're not going to, we'll take a quick look at it, but mostly in this class, we're concerned with 2 and 3, substitution and elimination. All right. And I hope for most of you this is something of a review. You should have had these previously, and hopefully we're just bringing it back to mind. Well, okay, I have in my notes to do a graphing example. So I'll do a graphing example as best I can. Clearly, if you have a graphing calculator or you use a program like Desmos Online, it's going to be much more accurate. And what we used to do in the good old days, before everybody had their own computers, we used graph paper. Does anybody not know what graph paper is? Does anyone know what graph paper is? Okay. There's lots of lines. Okay, so the problem we're going to try here is f of x. I'm just going to say y. Y equals 3x minus 4. And y equals 1/2 x minus 2. So since I'm going to have an intercept of 4 here, minus 4, so I should extend this. Okay, so the first equation goes through 1, 2, 3, minus 4, and has a slope of 3. So over 1, up 3. Over 1, up 3. And of course I have my brain ruler trying to draw this straight line. Now, for y equals 1/2 x minus 2, well, that's going to go through minus 2, but it's going to have a slope of 1/2, which means I'm going to go over 2 and up 1, over 2 and up 1. So it's going to be kind of like that. And it looks like, very approximately, they both might go through 1, 1. I wonder if that's true. It's minus 1, no, minus 1/2. So, already you can see with graphing, you can do better with a graph paper and a ruler. But it does at least get you, in the ballpark here. We know somewhere around here we're going to find the right number. Oh, I'm sorry. I did this. No, it's 1, 1. According to this, that's the right answer. What is that? -1. Why is that -1 equals 3 minus 4? Oh, because this is -1. I'm sorry. -1, comma 1. Comes up to -1. Oh, that's -7. I'm not really sure. Well, we're gonna do it use the other methods, so we'll come up with the right answer. All right. Substitution says one of my equations is written in a form like this: one variable equal some stuff. In this case, it's y. And I can plug this in here and get rid of the y. I'm substituting. This could be more complicated. Y could be multiplied by something, added to something. But I take this y and I plug it in here. So I get 1/2 x minus 2, that's my y over here, equals 3x minus 4 in this equation. And now I just have a simple equation in one variable. Right? Let's see if I can, I think I'm going to do something I like to do when I have fractions, which is get rid of them. I'm going to multiply through by 2. So I get x here, getting rid of the half, minus 4 equals 6x minus 8. So now I don't have to deal with fractions. I'm going to subtract x from both sides. I'm going to get 5x minus 8. And I'm going to add 8 to both sides. And I'll get 4 equals 5x, or my x equals 4/5. Why does that not? I guess that's where this point could be 4/5. All right, now once I have my x, I have my choice. I can plug it into either of these two equations, and I should get the same y. So let's try that. Y equals 3 times 4/5 minus 4. So I have 12/5 minus how many fifths here? 20/5. So I get negative 8/5. So my y should be negative 8/5. And as a check, because I probably made a mistake, I can plug 4/5 and negative 8/5 into my other equation as a check. So negative 8/5 equals 1/2 4/5. Well, why do I not think this is going to work? Minus 2. 2 is how many fifths? Oh, it's 10/5. So 1/2 times 4/5. I've got 2 here. 2/5 minus 10/5. Oh, it's negative 8/5. So I've done my check. So now I know what the right answer was. It was 4/5 and negative 8/5. Okay, this is substitution.
Is that just how you find where the points intersect, where the lines intersect?
It's just how you find where they intersect. That's right. Everybody's like seen this before today, I assume, right? You may not remember it that well. It's okay. You're gonna have a chance to practice it a little. Okay, so sometimes a problem just screams out for substitution because you already have one of the variables like this already set up to substitute. That's not always the case. And I'm going to show you an example of a problem that kind of screams out to do elimination. All right, so the problem here is 2x plus 3y equals 5 minus 2x plus y equals 3. Now, if I was going to do this by substitution, I want to keep it simple. I'd say, all right, well, I could make this y equals something. Y equals 3 plus 2x by moving this over. And then I could substitute it in the y over here. But the reason this really screams out, as I say, to do elimination is you can see that if I just add these two equations, the 2x and the minus 2x, the x will go away. I will have eliminated it. Now, the problems aren't always set up that nicely. Sometimes you have to multiply one of these by some number. Sometimes you have to multiply both of them by a number to get the x's and the y's to match up. You don't always have to add either. If it's more convenient, like if this were just 2x, you could subtract. Now, I didn't say this, but when I say add, I mean we have an equality here and equality here. So if I add this side to this and this side to this, I still have a true equality. Kind of like if I have 1 equals 1 and 3 equals 3, and I add both sides, it's still going to be an equality. All right? So let's go ahead and try this. Let's do this by adding. So we get 4y equals 8. And then I can just divide through by 4 and get y equals 2. Okay. That was pretty easy. I now still want to get my x, so I look back at my two equations. I can use either of them. So I want to pick the one where it looks easiest. And for me, I think, well, if I plug in a 2 here, I get negative 2x plus 2 equals 3. I subtract 2 from both sides, and I get 2x equals 1, or x equals negative 1/2. So again, my solution point is negative 1/2, 2. Now, again, with these, there's a very natural way to check. I used one equation, kind of, well, take that back. With elimination, I didn't. I can choose either of these or both of them as a check. So let's try this. 2, I'm going to use the first one, 2 times negative 1/2 plus 3 times 2 equals 5. Well, I can kind of do this in my head. 2 times negative 1/2 is negative 1. 3 times 2 is 6. 6 minus 1 is 5. So that one worked. And if I want to be really sure, negative 2 times negative 1/2 plus 2. Oh, equals 3. All right, good. So negative and negative cancel. 2 1/2 times 1/2 is 1. 1 plus 2 is 3. So these both check, and I know I have the right answer. That's elimination. So we have substitution and elimination. Let's do another one, and let's think about it. Let's try and think this out. Because there's almost always an easier way to do it, and a harder way. So I want you to look at this and think about it for a minute. And give me some ideas on which method you would use and how you would use it. 3x minus 2y equals 4, 2x plus y equals 5. Interrupt you, but with all this Halloween candy around, I had to give myself a stomach ache, so I'm picking something for it. Okay. Anybody want to stick their neck out before I call on you? Any thoughts on this? I want to emphasize, you can't go really wrong. You can do it either using substitution or elimination. You can get the right answer. There's no, like some people think in math, there's always a right answer. To this question, there's not. You can do it. One way may be harder, but it's not wrong, and you'll get the right answer if you do it carefully. The reason you want to choose is because if you find a simpler way to do it, you're less likely to make a mistake. Anybody wanna, yes?
Found it easier to use substitution.
Okay. All right, you want to tell me a little bit more? Which equation do we want to get in the, something equals something else form?
I use the bottom equation and put 2x on the other side with the 5.
Okay,
And
pause there for a second, everybody. There's a y here, so to get it by itself, y equals, I won't have to divide. So that's almost a sure thing. You see that? Okay, go ahead. Y equals 5 minus 2x. Okay, and then we're going to substitute that in other equation. All right? If you make the mistake, I want to show you what happens, because occasionally people will do this. It's an honest mistake. You try and substitute it in the wrong equation. All right, let's see what happens. 2x plus y. Okay, that's what I want to substitute. 5 minus 2x equals 5, and then, so 2x minus, that's 0, plus 5 equals 5. Now, as satisfying as it is that that's true, you can see it's not telling me anything about x or y. So if you pick the wrong, if you substitute back into yourself, this is what happens. You get an equality that's true, but there's no, variable left. Okay. Okay, let's just give this a quick try. So 3x minus 2 times what I'm substituting equals 4. Well, you see immediately now my y is gone, and I just have an equation with x's. I have to do a little work. Minus 10, minus is a plus, 4x equals 4. So I have 7x, and I add 10 to both sides, and I get 14, and oh, it's nice numbers. You don't always get nice numbers. Sometimes you get fractions. You just have to live with that. So if my x is 2, well, again, I have that choice. I can choose either one, but I can see if I plug it in here, I'm just going to have a y. So 2 times 2x is 4. Subtract it from both sides. 5 minus 4 is 1. So my y is equal to 1. So my point is 2, 1, point of intersection. And since I use this equation to find the x, I should probably plug it in here as a check. 3x, so 3 times 2 minus 2 times 1 is supposed to equal 4. 6 minus 2 is 4. Okay. So I've solved it and I checked it. Now, let's say I had gone a different direction. I said, I really want to do this by elimination, just for practice. Anybody, there's nothing I can just add right away or subtract to eliminate something. Does anyone have any suggestions on how I might modify one of these equations so that I can eliminate? I have to look at it and think about it. Anyone? Okay, maybe a little practice will come to you. To get the x to eliminate, I'd have to multiply this by 2, so this is 6, and this by 3. And sometimes you have to do that. But it'd be less trouble to try and eliminate the y. You can just multiply this by 2. So I get 4x plus 2y equals 10. And then I want to add these two. See, my minus 2 and my plus 2 go away. So again, I have 7x equals 14. I get my x equals 2, and I can again find out that y equals 1. So when you're doing these, there's kind of the mechanical part, how do I do it? But there's also like, you want to sit back and say, how can I make this easy for myself? Is there a way to do that? There won't always be, but oftentimes there's a easier way, make the numbers easier. And it doesn't matter if you don't choose the easiest way. It will still come out, it's just more work, more chance for error. Okay. Okay, so I'm going to go back to graphing for a second. I wonder what happens if I have two lines and they're parallel. So where do parallel lines meet? Now is that a no, I don't know, or a no, they don't meet?
No, they don't.
They don't meet, right? So something's going to happen when we try and solve this. We don't know they're parallel. All right, let me just make up two equations here. This looks like y equals x. And this looks like y equals x minus 1. Okay, let's see what happens when we substitute. Well, isn't that great? It's already set up to substitute. So I'm going to substitute this y into here, right? So I get x equals x minus 1. I subtract x from both sides and I get 0 equals minus 1. Well, that's not going to work, is it? Okay, kind of stuck. I didn't find where they meet. They don't meet. You should know that, you know, when you see something like this, two numbers that aren't equal, you probably have parallel lines. Now, there's one more possibility, and I guess I'll draw the graph like this. This will be 1, and I have an equation y equals x plus 1. And very sneakily, I draw another line. I can't really draw this, but my other line is 2x plus 2x. 2y minus 2x equals 2. I think that's actually my other line. You might say, wait a minute, they're the same line, of course. So what happens, well, maybe we don't notice that right away, and we go ahead and, again, we try and substitute. So let's see what happens. Here's my y, I'm going to substitute in here. So 2 times x plus 1 minus 2x equals 2. All right, let's do a little work here. 2x plus 2 minus 2x equals 2. And 2x and minus 2x is 0, so 2 equals 2. Well, that's true. This is what happens when you have the same line. See, the problem is any number that I can fit into one, I can fit into the other. And if you try elimination or substitution, you're going to end up with a true statement, but no information on x and y. So this should be your trigger to think, maybe these are the same line. I guess there's one more situation you might run into, which is actually pretty simple. So I might have one line like this. Could be horizontal or it could be vertical. So what is the equation? It's like y equals 5. And I'm just going to make up something like 2x minus y equals 3. I'm not going to try and graph it. I'm just going to try and solve it. Well, clearly it's perfect for substitution. I just have 2x. I plug in my 5 equals 3. 2x equals 8. X equals 4. So I know that at 1, 2, 3, 4, 5, I don't know where this is, but just make believe there's going to be some line through that point. So this is kind of an easier situation if you run into a parallel or a horizontal line. Okay. I hope this is so far pretty familiar. We're going to have some homework so you can practice it a little, get up to speed. Again, if you have problems with it, you can bring them into class, or you can come to office hours. But this is kind of a basic skill that you should have. As I pointed out, it will come up in business applications. It'll come up in just about if you're going forward in math, you need to meet this skill. All right. I want to show you one more thing, which again you can. I hope by saying the following words you will not tune out. It won't be on the exam. But it's nice to know that if you were some computer programmer somewhere and you wanted to write a program to solve systems like this, you can use Cramer's rule. Well, Cramer's rule comes from just taking this equation with constants, but ones we don't know, and solving it. And we solve it, and we come up with a solution, and we present the solution in a very specific manner, right? So in order to explain that, how that looks, I first have to bring up this idea of a matrix. A matrix is just a series of columns and rows with numbers in them. In particular here, we're interested in this matrix. I put this into standard form, A, B, C, D. Now, when you have a matrix, there's a way to turn a matrix. I guess I should put some labels here. There's a way to turn a matrix into one number, which is called a determinant. And the way you show that is, instead of these curvy lines, you just put straight lines. Has anyone here seen the determinant before? Okay, a few of you. And in the case of this, which is a 2 by 2 determinant, determinants only work if they're square, 2 by 2, 3 by 3, 4 by 4. The determinant is just the number AD minus CB. Okay. So now you know the vocabulary. You just have to know how does Kramer's rule work. Oh? Question? No. Okay. So we put our equation in standard form, and to get x, our x, in the denominator, well, it's going to be determinant. We put A, B, D, E. In the numerator, we're going to put the same values, but since we're looking for x, we're going to substitute for A and D, C and F. For the y, we can do the same thing. But because we're trying to find what's in the y column, we're trying to find y, we put C and F here. Then we just use our determinant, CE minus FB over AE minus DB, our x. And this is going to be AF minus DC over AE minus DB. So it's a formula that solves every one of these systems. And if you're writing a computer program, well, this is nice because you see already you only have to calculate AE minus DB once, even though you use it twice. The other nice thing about this is, what if I had, I guess I'm going to have to change my notation here a little. What if I had BY plus CZ equals D? I'm going to have a lot of letters here. EX plus FY plus GZ equals H. IX, I never use I, I'll use it here. Okay, now I've got a 3 by 3, but I can use exactly the same formula and say x equals A, B, C, E, F, G, I, J, K, this determinant over B, C, E, F, G, I, J, K, except since I'm going for x, I'm going to substitute D, H, and L. Now, I have to learn how to find a determinant for a 3 by 3 or maybe a 4 by 4. You can get a computer, once you learn the pattern, you can get a computer to do that. So, again, not on the exam, not required, but I just wanted you to know that there's a kind of a mechanical way to do this. Short story. A couple days ago, I was doing the homework for calculus. I have to do the homework for calculus because I have to give the solutions to the grader. And there was a problem. It was 5 equations in, it was 4 equations in 4 unknowns. And back in the good old days, when I went to high school, we want to show you really tough in math. In the book, they have 3x3s and 4x4s, and you'd go solve them. And all right, let's give this a try. I just couldn't do it anymore. It's not smart enough. But I looked up on the web. You look up on the web, 4x4 system of linear equations, and a web page comes up, and fill in the numbers, solves it for you. So it's kind of like having just like multiplying. If you have a calculator, you can let the machinery do the work. All right, but you do want to get some facility with 2x2, and you will get that from the homework. All right, any questions about this? I hope, like I say, for a lot of you, it's just review and a little practice to get you back up to where you were one time. I think that's all I have for today. Oh, before you go, I'm sorry. I wanted to say, I posted online a sheet that says review sheet for second midterm. So you can go take a look at that. I want you to notice that the very first thing it says is everything on the worksheet, everything on the review sheet for the first midterm. So you can't just forget everything you learned. But mostly it'll be on what's listed. So that's the first thing I want to say. Second is, for the midterm, you are allowed, encouraged, to have a sheet of paper, two-sided, and you can write anything you want on it. Formulas, notes, things you want to remember. It's best to put things on there that you know, but you might not remember exactly. Like, laws of exponents, or, I don't know. I don't think you want to put Kramer's rule. But that'll be available to you during the exam. You'll be able to look at that. And then that's the second thing. Now you can go.